Hello, everyone. I am Shahab, and this is another session of Microsoft Zero to Hero. And in this session, we will talk about Kusto, a simple and powerful tool for exploring, analyzing, and gaining insight from all kinds of data, structured or unstructured. Today, we will have Brian Bønk with us, that he will introduce us to the tool and how we could leverage the capabilities of this Kusto. Okay, as you already know, we are part of Microsoft Learn community. And if you want to gain more insights about what we are doing, you could follow the two links that we have in here, aka.ms/Microsoft Learn community and aks.ms/learning rooms. You could follow us on LinkedIn, Instagram, YouTube, and if you have any questions, you could get in touch with us, and we will be more than happy to help on the topics. As always, be friendly and respectful to everyone, listen to different opinions, and be kind and patient. Without further ado, I would like to invite Brian on the stage, and let's start this session together. Hi, Brian.
Hi.
Welcome.
Perfect. Hello, it works.
Great. Yeah. That's always like the most frightening part, like something is broken and you don't know if it works or not. Okay, great. Please give an introduction of yourself, and afterwards the stage is yours.
Sure, I will. Thank you. Well, my name is Brian. I'm from Denmark. I am so happy to be invited to this Zero to Hero session here. And you're quite right. We are going to talk about the Kusto Query Language, the Kusto. What is Kusto? Where do we start? How do I get started? Because it's just another query language. Do I really need to learn it? And how do you actually, what do I use it for? So that's the session for today. Yes, sure.
Perfect. Sounds great. Then I will share your screen, and fingers crossed.
Thank you. Thank you. And thank you for everyone joining here live. I hope this will also go out on YouTube later on. So wherever you are in the world, welcome to more or less 57 minutes of enjoyment. I hope I will do what I can to help you get started at least with the Kusto world of data.
Definitely.
I have a small slide about myself. My name is Brian. I'm a senior principal of a company named IntelliShore here in Denmark. IntelliShore is a part of the Solita group, if you know that one. I do a bit of blogging. You can see the blog at the third row to the right here at decode.bi. That blog contains more or less only real-time intelligence, which is a part of the Kusto environment, which I'm going to talk about today. I'm also a Microsoft MVP on the data platform. If you want to follow me on LinkedIn, because I also do a bit of knowledge sharing on LinkedIn, you can do it on aka.bi/follow. That will guide you directly to my LinkedIn profile. After this session, if you need the slides, you can get them on my GitHub account that you can find on aka.bi/slides. As I just told before we went live here, I also built a reference guide to learn the KQL language, which is a big part of the session today. If you want to dive into that, then after the session, go to kql.how, and then you will find a full reference guide to the KQL query language. But let's get started, and let's dive into what is Kusto, and how do I go from not knowing anything to actually be confident in this I can do. So first of all, what is Kusto? Well, if you have ever worked with any of these services from Microsoft, Azure Sentinel, Log Analytics, the Azure Resource Graph, the Defender, then you have actually worked with the underlying Kusto engine, because all of these services leverages the Kusto engine from Microsoft. And the Kusto engine from Microsoft is the one giving power to the data that we work in the Kusto Query Language. That is why KQL Kusto Query Language, this is where it comes from. But in an analytical part of the world, how do I then use it? Well, we live in a world today where data is all around us. Wherever we pick up our phone, whenever we wear a smartwatch, whenever we start our car, that generates data. And that data is streamed to a server somewhere in the world. That data has a specific point in time. It has some specific events that are immutable. That means the data coming out is more or less unchangeable, because that's just a point in time status of the devices in your engine or in your clock or in your phones or something that in that point in time was streamed to the server. So it's immutable, and it is a continuous flow of data. Every time you click something on a web page, every time you do something in Teams, chat, open Word, send a mail, that generates what we call telemetry, also a log event being sent out to a server somewhere in the world. If you drive a modern car today for 5 kilometers, that generates around 1 gigabyte of data sent somewhere in the world. We need new ways of handling these gigantic amounts and volumes of data. It has a high volume, it has a high velocity, and it has a high veracity. The 3 V's, if you stumble upon those, then you are a possible candidate to use the Kusto engine. And when we talk about analytics, then we are into Microsoft Fabric, then it's called real-time intelligence. If you're in the digital transformation world, these are some of the buzzwords that you might also stumble upon. If you stumble upon some of these buzzwords, then you are also a possible candidate to working with real-time intelligence. Quality control, environment management, cybersecurity, and all those kinds of stuff. Imagine if you have data that is coming in on a continuous basis, and you need to handle that data more or less as they come in. You can't wait for the next top of the hour until the data warehouse has been updated. You need insights more or less now, and perhaps you also need insights historically on the big side of data, not big data, but the large volume of data. You might need insights on 10 trillions of rows every year in the last 10 years. We need to process that. That is also a way to do in real-time intelligence, because we don't need to pre-aggregate it. We can just get sub-second query time on large volumes of data. Speaking of analytics, Microsoft Fabric is the platform to use, and this is, perhaps you have seen this slide in different versions around in the past 2 years, where we now have real-time intelligence in the middle as a part of the Microsoft Fabric platform. If we zoom in on the real-time intelligence, then the real-time intelligence on the top here has 6 main areas. We can ingest data, we can put it in an analytical platform, we can put it in the Kusto engine, it's called a KQL database. We have AI on top of it. We can work with real-time dashboards. I'll come back to all of these later on in the session. We also have rules, real-time rules. Data Activator was the first name. And we can also now begin to build event-driven actions. All of this is packaged within the real-time intelligence suite in Microsoft Fabric. Next to that, we have the real-time hub, which is your one-way entry to begin to start with streaming data, ingesting live log data, the data types that I just talked about. And way out to the left, you will see some of the sources. This is not exhaustive. We have a lot of sources to work with within the real-time intelligence suite. Of course, no data in Fabric without the OneLake. OneLake is also part of the suite, but we have a special thing there, and I'll show you that in just a minute. And AI is upon us, so we also have Copilot to help us in real-time intelligence if we get lost or need help. If we zoom in on some of the areas, then let's start with ingesting. Ingesting is, oh, this is a bad slide. At the top, right next to the icon, it says event stream. I'm sorry, it should have been a black text. But the event stream is a UI, very, very easy, approachable UI, where you can begin to ingest data. And because prior to this session, I started an event stream because I needed a huge amount of data set in order to show you what we're actually working with. So let me dive in and show you what I did in order to set up my event stream for this demo. So let me switch back to Fabric. This is my Fabric environment. And on the top here, you will see, oh, sorry, let me move that one. There you go. This one is an event stream that I created. I just call it stream taxi demo because this streams in data from a demo dataset that Microsoft provides. If I jump into it, it's just an item in Microsoft Fabric. It takes a few seconds to load. While this loads, then the event stream processor is actually leveraging 3 different services from the Azure infrastructure. It leverages an event hub, which is where the data ends up when you begin to stream it in. It can do. It also leverages the Azure Streaming Analytics to do transformations. And we also have other services and event grid to listen to events when they happen on the one lake or in a blob storage or in your Fabric capacity. So out of the box, when we start an event stream, we get the 3 services, but we get the beautiful UI on top, and we can begin to configure this with mouse. If you don't have any data, then you can easily begin to work with demo dataset. Right here at your left side, you will see that I have a source named taxi demo. And if I need to add another source, I'll go into the edit mode. And in this edit mode, I can add a source. I can add the sample data set. And in the sample data, you will see that I have some options. I have bicycles, which is a rental shop where they rent out bicycles. I can begin to work with that. It's still just demo data set, so it's not live. I have this data set. This is the one I'm using today. This is the New York City taxi trips, pickups, drop-offs, fare amounts, all that kind of stuff. We have stock market data, we have buses, and we have some more stock data here. But for this demo, I have chosen the taxi one. If I close this one, there you go, and then I will add, perhaps just connect to a data source here. Let me show you here, because when I connect to a data source in Event Stream, I have a myriad of possibilities. I have Azure Event Hub, I have an RT Hub, I can connect to Amazon, I can connect to Apache Kafka, I can even connect to, Confluent Cloud Kafka. I can connect to different Azure services as long as they are in a change data capture environment. I can connect to a Google PubSub and all those kind of stuff. I can connect to a myriad of sources here, and these are out of the box. And Microsoft keeps on adding new sources continuously here. So perhaps tomorrow you'll have a new source. I don't know, but eventually we will have more sources as time goes by. If you don't have a standardized source here to begin to work with, then you can always, if I close this once again, and then add a source, I can always create a custom endpoint. This custom endpoint exposes the event hub behind the scenes here, and then that event hub provides me with the endpoint connection, the connection string, and also the SAS token, the shared access token, which you can then put in your application, and then they can stream the data directly to the event hub, and that event hub will then send the data into this event stream. When I have my data sources ready, then I can begin to transform it. And transformations is just, I can click this and then I can add different transformation. I can begin to group it. I can begin to add it, to filter it. I can join it and all those kind of stuff. But in order for us to have enough time in this demo to work with it, I haven't added any transformation because I can always do that later on in the Kusto database, just like I can in a SQL database. Then I've added a destination. This destination is an event house I created in my workspace. Let me show you that one right here back in my workspace. This is the event house I created before I created this morning. If I sound a little sore in my throat, that's because I'm not completely on top today, so sorry about that. Underneath any event house, there's also a KQL database, and the KQL database is actually where we store our data. So I connected my event stream to a destination in the event house in my KQL database, which I call 0 to hero. And this event database has a table called New York City Taxi. This table was created by the event stream when I connected the event stream to the destination, and then now I have data in this table. I'll get back to the whereabouts about this, but now you know the setup around event stream and how to get started here if you don't have any data. If you have data, just connect to it as I showed you, and then you can begin to work with it as I will show you in the rest of this demo. So about the event house, I need to change the slide here. There you go. The event house is based off a KQL database. A KQL database is a Kusto Query Language database. It's the proprietary database from Microsoft. It brings you all of these plus more capabilities. It has unlimited scale. So whatever scale you have in data, it will be handled by the KQL database. It connects to any data source, any data format. Any is perhaps a bit too over the top because any is not images. It can't read images yet. I hope it will later on. It handles structured, semi-structured, and free text data. Whenever you need transformations, they can be done live, even on complicated data structures. We can do streaming data, of course. It is, as I told you, the 3 Vs: high performance, low latency, high freshness, so velocity, volume, and veracity. And it is built out of a time series database. So if you have ever worked with another time series database outside of Microsoft, this is the Microsoft option to begin to work with time series data. And the reason for we have such a great capability in speed and query speed and all that kind of stuff is because everything is indexed and partitioned for you. You don't have to do anything to maintain it. You don't have to ask your DBA to refresh the indexes or refresh the statistics of a table. That is handled for you by the engine. So quite impressive. If you don't have any access to a Fabric environment or Azure Data Explorer or something, you can actually get started for free. Azure Data Explorer.azure.com/free cluster. That will give you a free cluster with a capacity of 2 gigabytes. That is way more than you need for a quick demo. Oh, I see a question here. When adding a data source to an event stream, how can we add custom sources that aren't listed? Good question. Custom sources, let me show you that one. It just needs to reload. But the custom sources is actually a custom endpoint. If I go back to edit mode, then I add a source, then I can add a custom endpoint. This custom endpoint, let me just say here, custom, if I could spell custom endpoint, add that one. Then this custom endpoint, when I publish the event string, this will expose the underlying event hub when it loads, and when it gets green, there you go. Now I have my event hub ready. You'll see here and at the bottom, I have my event hub. I also have an AMQP endpoint and I have a Kafka endpoint exposed to me. So if my application can send data to an API or an endpoint, then just send it out to the event hub, then you're good to go. Because this event hub, if you go into the details, you will see that you have the SaaS key authentication. You both have the, I can surely show this because this will be deleted afterwards. I both have the connection string, so the endpoint, and I also have the primary key. So this is the SaaS token. So these two, the combination of these two actually gives me the possibility to add a custom source to my event stream, send it over to this event hub, and then the event stream will begin to pick up that data set. That's actually quite easy to set up an event stream. I don't know about your application, but it is quite okay. Let me delete this one because I don't need it right now. Okay, back to this. You can get a free cluster by signing up here, and it won't cost you anything, but you won't get all the features. You'll get some of it because some of the features will require a bit more capacity than you get out of this free cluster. If you want to work with this more and learn more, then the detective.kusto.io is perhaps the best gamification I've ever met on learning a new scripting language. After this session, go to detective.kusto.io, sign up there, and then you are in a learning path, being a detective, trying to solve mystery cases using the Kusto Query Language. And you start very easy on season 1, then you have a season 2, then we have a Christmas edition, and quite recently we have gotten also Fabric editions, so we can also now begin to learn the Kusto Query Language using Microsoft Fabric. So try to learn it. It is quite impressive and quite funny to actually go there and learn about the Kusto Query Language. So when working with the Kusto Query Language, we have a different approach of working with the data. If you are from the SQL world, then you might normally see the things on the left. On the SQL world, we have a data set, then we have the calculation, so that's the select, columns calculations, row-based calculations. And then we have the typical where, the group by, and the having. This is the typical way of writing SQL. I know there are details in the abbreviations, but this is mainly the approach for writing SQL. On the right-hand side, for every row you have in KQL, I'll show this in just a minute. For every row you have in the KQL world, you have a single data set with calculations and with filters, with everything. But you also need to know that if a column is not in the preceding row, then you can't use it in the next row. I'll show you that in just a minute in the demo. It'll make sense for you when we get back to this slide. And we'll get back to this slide after this demo. So if I jump into my KQL database, you will see that I have this table. And I also promised to show you how to get data to OneLake, because when you initially load data to your event house and your KQL database, the data will be stored in the proprietary data format of the Kusto engine. It won't be saved to OneLake by default. At the right-hand side on your database level, you have the database details. At top, you will see, oh, sorry for that one, it should have been a box. At the top, you will see the original data size and the compressed data size, because when the data enters the engine, it is automatically compressed in a factor between 6 and 10. So right now, it was originally 171 megabytes, but on disk, it only fills up 24 megabytes, and the 24 megabytes is the thing I'm being built in Fabric. But the important part here is the OneLake. The OneLake is by default disabled, this one. So if I need data copied out in OneLake, I just enable this one, click enable, and I can then select apply or not apply to existing tables. And then by magic, then the engine begins to stream out data to my OneLake folder. It is not live because the engine behind the scenes translates the data into Parquet files, and the optimal Parquet file has a specific size range. So that size range is the engine trying to optimize before it sends out the data to OneLake. So right now you will see that it is, right now you will see that it is 100%, but that is not entirely true, because right now it tries to translate what we currently have in the table, the New York City taxi table, and sending that out to OneLake. So when we get back to the OneLake, I'll show you that we have data in the OneLake in just a few minutes. But back to my table. The table is called New York City Taxi. It has some columns to the left. It has a vendor ID, a pickup date time, drop-off date time, and so forth and so forth. And when I click a table, in the middle, you will see that I have some insights. Let me remove this one so we have more space. I have some insights to the table. I see at the bottom, I see a snapshot of the data set that I have, so I can see that this is what the data set looks like. That's quite fine. And on the schema insights, I can begin to see what kind of data set am I looking at. What's the distribution of vendor ID? Well, I have two unique items. Values, I have 1 and 2. In passenger count, I have a minimum of 0 and a maximum of 8. I can see the distribution here, and so forth and so forth and so forth. So I have some statistical insights to my data. And on the top, I can also see the ingestion of this data. If I allow myself to zoom out just a tiny bit, and I will zoom in again so you can see it, because then I will also get the dates and times here. At the top, I can filter on what kind of data range, what I want to see my ingestion rates in, and I can then group it by an interval. And if I zoom in like this, there you go. If I zoom in like this, you will see that I can hover each column, and from 0 a.m. to 12 p.m. today, I ingested 615,000 rows, and from 12 p.m. until right now, I've ingested 524,000 rows live from this demo data set. So let me zoom in a bit again so you can see what we are doing with. There you go. So let's work a bit with this data set. In order to work with the data set, we need to do the Kusto Query Language. This is where we begin to learn new stuff. When you create an event house and a Kusto database in Fabric, you get a query set. A built-in query set is just a look at it as a notebook for your queries. It can be compared to a SQL pane in your SQL Server Management Studio or something like that. It's not stored it is not storing any scripts anywhere. It is just a notebook where you can save it internally in Fabric. So in order to do my select star from New York City Taxi, then, as I told you before, each line of script is its own container in a calculation and a result set. So in order to do that, I need to type the table name first. So New York City Taxi, and then I'll dive around this, what it means, but you might guess it that now I'm just taking the first 10 rows. The first 10 rows of data, and then I get the data set. Whenever I execute a query in the event house, I get also get a stats where I can begin to get insights of this query. But I'll leave this for yourself to discover when you get there, because it has a lot of information and we won't be able to cover this within the next 33 minutes. Then we are off. So this is the first query that you might do in Kusto Query Language. But if you come from a SQL world, you might just write select top 10 star from New York City Taxi. This is what you would do in SQL, and lo and behold, the Kusto engine also accepts SQL. So if you know your SQL, you might do, because that's more or less a commodity today, then you can begin to write your Kusto, or sorry, to write your queries using the SQL language, and then you will get a result set out of it. When you are done and you say, hey, I might say where, I don't know, vendor ID equals 1. Let's say this is my query, and I'm now done with this one, and I would like to learn Kusto. How does this look in Kusto? Well, it's not harder than writing explain on top of this query, execute it again, and then now the output is no longer the dataset, but it is the query from SQL translated into Kusto. So now I have a select from the New York City Taxi. And here we will see a strange thing. The where clause is moved up. I'll get back to that in just a minute. Then we have a project operator. The project operator is actually just a column selector. What kind of columns do I want? Because if you look here, I do a select star. Select star is all the columns, and the select star is not a best practice in the SQL world. It's the same thing for Kusto. Only select the columns you need. So if I remove, I don't know, some columns, and I execute it again, then I will only get the selected columns.
Brian, sorry for interrupting. Do you mind to zoom a little bit in here, because there is text, and I'm afraid that it wouldn't be visible for like every audience.
Sure, yep. No problem. Is this better?
Yeah, way better. Thank you.
Sure, thanks. No problem.
And we have a question. So
we have a question. If the data is distributed across different OneLakes in different tenants, is it possible to run a federated KQL query across all of them without transferring the data into one tenant? Ooh, good question. You are perhaps a bit ahead in the session here, but I'll answer that anyway. Yes, if data is distributed across different OneLakes and different tenants, with OneLake you have the ability to share data across tenants. You can just share data, and then you get the pop-up that looks like OneDrive, and then you can share your data from OneLake. When that data is shared, then the receiver of that data can then create a shortcut to the data. And a shortcut is just a pointer to the data in a different tenant or a different place. And then that shortcut can be read by your Kusto engine. Do I have time? I'll make time. I'll show you in just the fastest way possible. So on the database pane, I can new, and then I can create a OneLake shortcut. Imagine this was a OneLake outside of my tenant. It can fairly be outside of my tenant. If I then click the OneLake, then I'm presented with whatever data I have access to. Perhaps I have a lake house somewhere else. Let me see. This one. Next. In this one, there's nothing here yet. Okay, there's nothing there. Let me find another one. Tables. There you go. Here I have, I don't know, tables nation. This is now a table. It's just Parquet files, and I can select next. Then I am now creating a shortcut to my event house. This shortcut is just a pointer to the data. And there's a special thing about shortcuts in the Kusto world, because look right here, I have this accelerate. The accelerate is where the Kusto engine pre-processes the data, reads it into the KQL database where you are in, and then you will get the Kusto speed of that data. If you deselect the accelerate option, you will only get the speed of the one lake. But let me create this, and now I have, if this was a lake house outside of my tenant, I hope this works. Live demo is always interesting. One shortcut. There you go. Now I have a shortcut, and this is a shortcut that exists outside of my event house, and it can also exist on a different tenant. And I can actually now begin to query the shortcut, and I can begin to do whatever I want with it. I hope that answers your question quite enough here.
I myself have a follow-up question in this regard. I remember when I was doing developing database, like SQL Server database, we had the same concept as linked servers there that you could connect to. But the query, as far as I remember, was running on the other server, and we get the data back from that. Yeah. Where is the queries actually running when we have shortcuts in here?
That depends on the shortcut type, because if you do an accelerated shortcut, then it reads from your local instance. If you do an unaccelerated shortcut, it reads from the one lake where the data is residing. But the accelerated shortcut also reads from the one lake where it resides, but it only reads data in once. And then when that data is updated, it updates it to the shortcut again.
So
you might get a double read on that one. So, but just know. Yeah.
So the accelerated one is kind of copying the data on the local instance and then running the query over that.
Yes.
Another question from Mahdi. I will also share.
Data holders don't want to grant copyable access to others and only want to allow federated queries for final insights. Will this method protect against copying raw data? Not entirely, because when you have access to data, you always have access to save it somewhere else. You can always, when you have access to read data on any engine, no matter what people do, you can always save it somewhere else. I can always save it to Excel, and then I can send it out to Facebook or LinkedIn. So no, and this problem exists in every database concept you will find around the world, no matter what you do. But you can do a so-called followed database, where if you have a Kusto database somewhere else in the world, you can link to that database from Event House, and then you can actually query that database with the exposure of the security on that database, where you as an end user can only read the data you have access to. So both yes and no to this question. I hope it's not always funny to answer no to a question, but I'm sorry, but that's actually the situation as it is with any other database systems around the world, no matter what you do. As long as you can read the data, you can always move it, copy it, save it somewhere else. But you can do, of course, row-level security, object-level security on that stuff. So back to the query. Now we have learned to go from SQL to Kusto, and now we can begin to work with our query. So if I go back to my slide deck, and I'm trying to switch slides here, then you will see that the SQL role is select star from New York City Taxi. In KQL, it's just table name, give me all the data. If I want to filter it, then it's just every new row in Kusto is just starting with a pipe, and then where vendor ID, and then I need 2 equal signs. It looks like a Unix kind of system, but it's not. Just trust me, it is a proprietary database, but you need 2 equal signs because you also have equals with strings where you can search on case sensitive and case insensitive. There's another question. It's possible to grant federated query access, but implemented an approval process for each query originated from collaborators? No. You need to do the same security setup on your data as you do in any other database. If people have access to the database and have access to the data, they can read it. If they don't have access, they can't read it. You have the same problems around the world in every database setup. You can't pre-approve a query unless you have a very, very strict setup where people can't execute queries, but they need to go through a proxy. So sorry, but no. Yes. If I want to do an order by, that's also the same thing, order by, just with a pipe. I'm trying to do it here. I can also do a count. Then I need to, again, remember to type in the table name first, and do a pipe, and then the count. Let me show you this in just my table here. So New York City taxi, and then just count, execute that one. Then I get, at the bottom here, I get 1.6 million rows right now. And if I run it again in a few seconds, I might see more rows. Now I just got 400 more rows. So this is live. It is actually ingesting data as we speak. The next examples here, I'm showing you this because after, when you get the slides, you can get the scripts and then you can run it yourself. As I told you, the project operator is the column selector. So if I only want different columns, specific columns, I can do project. I can also do project away. That's a different way. That's the other way around. If I want to remove some columns, I can do project away. Let me show you. So New York City taxi. If I execute this one, then I have these, I don't know, 10, 12, 13 kind of columns. And then in the next line, I want to do project away. Then I want to remove pickup location ID. Now the pickup location ID is not there. So this is the other way around. This is unselecting columns. This is quite powerful because I can now do select, and then I can also remove columns. If it is faster to write the remove columns, then I will do that. If I have 1,000 columns and I only want 999 columns, then it's far easier to remove one column than selecting 999 columns. So a bit, yeah, sure.
Do they have different precedence order, or is it like if I say project away before project, will this column be included?
Ooh, then we need to go back a few slides because I told you that every row is its own data set. So if a column is not visible or included in the preceding row, you can't use it in the next row. Let me show you that one.
Yeah.
If I remove this and put it up here, you will see quite fast that I get a squiggly line on the pickup location ID because it is no longer in this row. It doesn't exist in this row because it is removed up here, right? So I can't use it here. If I execute this, then it won't work. But I can then do this one. That's the same thing.
Yeah.
So every row, so this is its own result set. The next row is also its own result set. Oh, I can't. There you go. This one is also its own result set, and this one is its own result set. So if I do something funny, because I can actually write more than one query length, where clause, I can actually write where vendor. If I could spell, I can't. Oh, I removed the vendor ID. Let me put in the vendor ID. There you go. Where the vendor ID equals 2, then I won't get anything. Why? Because right up here, I removed all 2s. I only got the 1s. So this one is based out of this query. And in this query, I don't have any 2s. So when I filter this one, I won't get any data. So when you begin to build up your Kusto query, remember that every preceding row is its own result set. And if you don't have that query, or sorry, that column, that calculation, that something in those preceding rows, you can't use it in the row you're in.
Yeah, great. Thank you for explanation.
Sure. No worries. The next example here is I can also do row level calculations. If I want to do row level calculations, I need to use the extend operator. So let me show you that one. I will remove some of this. And then let me say extend. Then I want to calculate, I don't know, total fair, if I could spell, sorry. Total fair, sorry for that one. Total fair amount. It goes really well. Equals, then it can be total amount times, I don't know, 1 punch, whatever. This is just an arbitrary thing. then I'm actually doing a row-based calculation. And this row-based calculation gives me a new column called total fair amount, and it is to the right. And it is, and I can move it, of course, it is to the right in the result set because it is just where you put it in the calculations. If I did not put any name before this, it will just give me an arbitrary column name called column 1. So remember to put in a column name when you do row-based calculations. And the next one is, I can also do summarize. So row-based calculations is just do these things with this column. But I can always do a summarize. And imagine that I have a select statement where I want to summarize the passenger count by vendor ID. Then on the left-hand side, I have 5 lines of code to do that. On the right-hand side, it's actually only 2 lines of code. Let me show you that one. So New York City taxi, summarize, summarize, sum of passenger count by vendor ID. There you go. And look how fast it was. 2 lines of code over, how many rows do we have? 1.1 million rows. It actually only takes, 0.079 seconds to do this calculation. Imagine doing this in SQL. Unless you have a good indexing and all that kind of stuff and you pre-build stuff, then you will have this. In the KQL world, it just works out of the box. If I use extend for if, but can you use it to group by summarize?
I think there were 2 questions. Let's see the first question. So you can't do a count and group by via extend. It's the first question, or could we?
Yes, you can. You can do some arithmetical grouped calculations, but why do it? Because it just add complexity to your query. Because when the engine accepts the query, it does its own internal optimization to execute that query. So why do it that way? Why not do it easily for the end user to debug it when they want to query it? So just write your extend and then do a summarization on top of that afterwards. That's way easier.
Let's see the second. If using extend for, but can you use it to group by summarize?
I think that's the same question, right?
Yes, you're right, because I think it was a different.
And also see summarize dyslexic, so it's fine. I think it's good, but good question. But yes, you can do all these kinds of crazy stuff as you can in SQL. But why do that? Why not keep it simple so people can debug it afterwards? Because the engine will still do a sub-second query for you. Perfect. So let me go back to the text, because all of these you will have afterwards when you download the deck. So now you might understand that whenever you are writing your Kusto Query Language, the funnel keeps getting smaller and smaller and smaller and smaller. So perhaps you do a filter, then you do a where clause, then you do a project something, then you do a row-based calculation, then you do a filter, then you do another summarization of something, and then you do another filter. This all comes down to, it looks like a funnel because the data set gets smaller and smaller and smaller, or narrower and narrower and narrower and narrower. This is also one of the first things to know when to optimize Kusto queries. Whenever you do a filter, try to put it as far up as you can, because the faster you can narrow down the data set, the faster the query will be. Is it possible to use KQL in combination with Apache Iceberg or Delta Lake? If yes, yes and no. If you do a shortcut, if the data is residing in one lake and you do a shortcut to the KQL database, then you can begin to read it. What you just saw on my shortcut here, this shortcut is actually just a Parquet file. And I can begin to query this Parquet file if I do, I think it's called external table, then it's called nation. Come on. There you go. This is just a Parquet file. And in order to read a shortcut, I need to use the external table option here. But this is just a shortcut to a Parquet file. And this Parquet file has been accelerated. So it is now residing with its data in the engine with way faster query times. And I don't think I have that much rows yet. No, only 25. But imagine that I had 2 million rows or 200 million rows, then it will still give me a snappy query performance. So if the file format is supported by OneLake, you can do a shortcut to it. If it's not, then you can't. I have an ongoing dialogue with a different person who has a JSON file stored in OneLake. Can I do a shortcut to that one directly in Kusto? No, you can't. You need to do a supported OneLake data format where you can read in Lakehouse. Then you can also read it in the Kusto database as a shortcut. I hope that explains enough. But this is just to give you an example of how you can begin to work with the Kusto Query Language. This is a lot. We only have 13 minutes left, but let me tell you something. Whenever you are working with Kusto and data, normally in data, you might want to build a start schema because that's the way that's most effective for the normal engine, the lakehouse, the warehouse, the SQL server, sort of kind of stuff, because then you're minimizing the data volume. And this might be mind-boggling, so bear with me here. So let me tell you a bit of a joke, but it's not a joke, but it's still okay. Forget everything you know about query performance versus data types and data modeling best practices when working with your Kusto database. Not in SQL, not in Lakehouse, not in Warehouse, only Kusto database. I can't say this enough. Why do I say that? Because a single table can be a good option. If you have a broad table, it's quite fine. The data will still perform. If I have 20 million rows, 20 billion rows in one table, I can still get sub-second query performance without building a star schema in Kusto. It's quite fine because everything is indexed and the engine has a different way of handling data. It's quite fine. If you really, really, really want to build a star schema, then go ahead. But when you put it into Power BI, you'll get many-to-many relationships, because when you work with data in the Kusto database in Power BI, then you will likely do a direct query because you don't want to import 20 trillion rows in Power BI. That will just break Power BI. But then you'll do a direct query, and direct query can't figure out the granularity and the statistics of each column. So it'll just default back to many-to-many relationship. And that's quite fine because everything you do is being query folded back to the KQL language in Power BI and executed at the engine level. And the engine level just do a join and easy peasy. If you have dimensions, they can be flagged with is dimension equal true. Then you help the engine to put up the where clauses far up in the KQL statement. If you have dimensions less than 1 million rows, it can be more optimal to have an import. Then you have a hybrid model. You have both an import and a direct query. That might give you a better performance. And the last but not least, and hold your horses. Oh, another question here. Is the Kusto query engine fully proprietary to Microsoft environments, or is it possible to use it in development custom web applications similar to the Trino engine? Oh, good question. There is a Kusto in a container. And sorry for the name, I didn't make it up. There is a product called Kustainer. Look it up on Google. The Kustainer is the Kusto engine in a container, in a Docker container where you can mount it to somewhere else, and then you can just begin to work with it as a custom web application. So sure, the Kustainer is a Kusto environment in a container. So yes, you can do it in a custom web application, sure. But it is outside of the Kustainer, it is only on Microsoft environment because it is proprietary to Microsoft. Okay, but last but not least, and bear with me here because you might shout at me and that's quite fine, but trust me, it works. Integer and decimal are slow joins compared to strings. Why is that? Because we have always been told that integer and decimal are the fastest joins in SQL, but integer and decimals are not indexed in the same way as strings are in Kusto. So when you are joining on strings, you're actually leveraging the indexing way that the Kusto engine works way better than joining on an integer or decimal. So if you have a business key that's a string, just do a join on that string between the two tables and you're good to go. You'll get way faster query times than you will do on building a new surrogate key with an integer and doing that join and those kinds of stuff. That'll just slow down your query in completely. It might be mind-boggling, but use this as a lookup to when you want to build your Kusto query language. If you are as old as me, you know this guy. It's called He-Man. And this is when I try to tell people, when you want to use Power BI with Kusto, then let Power BI build the Kusto query language. Just use the direct query mode. That's quite fine. Either in Power Query or using DAX, because everything you do in Power Query, not everything, but 95, 96, 97% of what you do in Power BI is being query folded back to the engine, and then the engine does the execution for you. Or build a Kusto function. What's a Kusto function? A Kusto function is look at it as a store procedure from the SQL world, that you store a query set, a query on engine with the possibility to put in parameters. Let me show you this. But we also have additional functionalities. So this might be a function. And let me guide you through this in just this one. The first part here, creator also function, that's just like create store procedure, then give it a name. And then in the parentheses, we have the parameters. This is two strings, time window and bucket. Then we have the query. This is a cross cluster query. So we are connecting to a cluster called help, database called sample logs, and raw syslogs. That's the table. And then we do some filtering where timestamp does something, and then we do a summarization and we do an order by. In order to execute this, we just call it get syslogs with 1 day, 5 days, and 1 hour, and then we're good to go. If you put this into Power BI, you will let the engine do its magic on your functions quite easily. Let me go back to this part here, the ago time span time window. What is that? Well, the Kusto engine has some quite effective time filtering, time and date filtering, where we don't have to think about what's today date. We can just say where the timestamp, this is a column, is larger than ago, and ago is just telling the engine, hey, filter this data based on today's date, but go back or forth in time. So ago, and then the time window, that's the input string. So that's, in this case, it's 5 days. So give me all the data that is younger than the last 5 days. The next one, then I do a summarization. Then you know this one, this is a count by name, and then I do a bin. A bin, what's that? Well, imagine you have a data set, and then you have 10 buckets, and that data set you need to put that in 10 buckets. A bucket is a bin, so it tries to divide that data set in equal sizes and put it in each bucket. That's a bin. So the bin operator, then it calls the timestamp, so that's the column here, and then I put it in a time span in the bucket. So the bucket is also an input string, and in this case it's 1 hour. So give me the data set in the last 5 days, but group it by 1 hour. I could also group this by 1 day or 1 second or 1 minute or 1 millisecond. And these are more or less free text. So 5D, 5 days, 5M, 5 minutes, 5S, 5 seconds, and so forth and so forth, 5 years, 5 quarters. You can actually just write this in pure string. And imagine the possibilities here. Now you can begin to do granular analytics on your data set at Power BI level, where you begin to change the granularity of your data set that you retrieve in Power BI. Imagine the possibilities that you can do here. Let me go here. We can also do some visualization. In order to do that, I need my slide so I can copy it. I need to find it. It's here. And I need to copy this one. Let me copy this one out. And I have 5 minutes left, and I'll be fast on this one because it is quite nifty.
We have another question, but maybe answering it after your demo.
Sure. What's the question?
Okay. I bring it up.
Is there an official or comprehensive source to check KQL benchmark for massive data set with access to raw data in order to compare performance against other engines and custom setups? Yes and no, because if you were fast enough to see it, then I actually have a workspace called TCPH. TCPH is the benchmark for querying data in large data sets. I'm doing a TCPH comparison right now in order to figure out the TCPH 25 standardized queries. How do they perform on large data sets? I won't show you any takeaways there yet because I need to validate this with Microsoft. I'm working with this with Microsoft right now. But yes, there are being made comprehensive benchmarks with KQL versus SQL versus what do you call that? Other search engines like Elasticsearch and those kinds of. Those are being made as we speak, but they are not public yet. They are still closed down because we don't want to expose anything that is not fully correct or validated. So yeah, it's on the way. What I just copied out here is actually a way to show you that whenever I have done a query, this is my query. It doesn't show any data because it does not have those kind of data sets. So let me do this one and we have now 25. Then I'm filtering out everything and execute this one. This might be, imagine how fast this was, 1.1 million rows, and it just gives me this without any fuss. Imagine I want to render this. You actually have a render operator directly in Kusto. You just call it render, and then whatever chart you want, you have different charts. If I execute all of this, then I won't any longer get the, I'll just zoom out just a tiny bit so you can see it. I won't get the dataset anymore, but I will get a visual. So let me filter this down to, let me say 24. Let's see what happens. Do we have data? No, we don't. 22. Do we have? There we go. Now we have quite a rendering chart of what is happening with my sum of passenger count over the pickup date. So how many passengers do I have per day in my New York City taxi? Quite amazing. One last thing before I end this session, you can also do outlier detection. This script is also a part of the slides when you download it. It does some quite easy stuff because let me zoom in just a tiny bit so you can see it again. There is a range operator, which takes a arbitrary variable. Then I want to range this from 0 to 364 by a step of 1. It gives me a year. And then I name all of these years from 2023, January 1st, January 2023, and then 364 days until New Year's Eve. And then I put in a random operator by 10. And then for every first day of that month, I add that by 20 to get an outlier. Then I do a make series. I won't come back to make series because that is an entire session by itself. But trust me, then I can begin to render the anomalies. And look at this. This is actually a rendering of the anomalies of the data. The anomalies is all the plus 20 that I added to my data set. And the rest is just whatever data set I have. This can then be added to whatever visual you want. I can add this to a dashboard, to a new dashboard. Dashboard. And I can call this anomaly detection, create this one. And without further ado, I don't even need to open Power BI. I now have a real-time dashboard with this in it, and I can begin to edit it, and I can make this a bit larger so I can see it. Then I can save it, and I can go back to viewing mode. And then I have, lo and behold, a visual, and I can begin to work with my real-time dashboards. The real-time dashboards is also part of this session, but I don't have any more time. I'm sorry. But this is a free offering. It doesn't cost you anything other than the queries it executes against the engine. So you don't need a Power BI license to build real-time dashboards. It's just a part of the service. I am now on top of the hour. I was a bit rushy on the last part here. I'm sorry for that one, but I hope you got it. If you need help on anything, just please reach out to me on LinkedIn. I'll gladly help you. You can get these slides afterwards. It will take an hour or two for the slides to publish on GitHub. So please be patient, and you will find them on the aka.bi/slides, and then you will find the slides there. If you want to hook up on LinkedIn, aka.bi/follow, I'll happily follow along. And if you need help, you can also contact me on LinkedIn right there. If you want to learn more of real-time intelligence, decode.bi, and then you're good to go. Thank you.
Great. Thanks, Brian. I think we shared also the links in the chat, but one last question, if you have time for it, because
how does Kusto pricing work in Microsoft environment? Is it fully serverless, or do we need to select a VM? Ooh, good question. In Fabric, you have the capacity, and the capacity is the fixed price, and the Kusto engine just consumes your capacity units based out of what you're doing. And it only consumes the capacity units as long as the engine is up and running. If you don't use the engine for, I think it's 5 or 10 minutes, then it goes to idle, and then you don't pay for it. So you only pay for the capacity unit and the engine when it runs in Fabric. If it's outside of Fabric, it's in Azure, then it's called Azure Data Explorer. And Azure Data Explorer is based out of a standardized VM set. It needs at least 2 VMs in a cluster. And those VMs are I think it's a list of 5 or 6 different VMs that you can select from a very tiny one to larger ones. And that VM, of course, it costs you something. And the cost is quite visible and transparent on the Azure website. It depends on the region and the price comparison you have with Microsoft, all that kind of stuff. But you can spin up a VM outside of Fabric, and then it's just 2 VMs at least, because you need a main cluster, a main node and a slave node. Sorry, that's just a compute node. Or you can do it in Fabric on the capacity level. So.
Amazing session, Brian. I really learned a lot about Kusto because I was using it, I think, a couple of years ago with Application Insight. I think it also has like
Application Insight, yeah, sure, yeah.
Yeah, environment query or telemetry data and metrics. And now
because underneath Application Insight, you have the log analytics workspace, and that's just Kusto again. So
yeah. And also the audience are thanking you for your answering.
Sure. Always a pleasure.
Precisely. Great. Okay, then I think that's the end of the session. Thanks for everyone to participating. Thanks, Brian, again for taking your time and being with us. Then wish you a very nice weekend and see you next week, hopefully, guys.
Thank you for having me. See you.
Bye.
Bye.